Let's solve the example 2 in this exercise. So we are to evaluate the integral from -1 to 1. The integral of -1 minus s squared to the root of 1 minus s squared. Then also the integral of s squared plus y squared 2 minus s squared minus y squared, all s squared plus y squared to the power 3 over 2 dz dy dx by changing to cylindrical coordinates. So here we must note that this is for z, this is for y, this is for y, then this is for x. So what we need to do is to convert these coordinates are all Cartesian coordinates. They are in terms of x, y, and z. But we know that in cylindrical coordinates, dz, dy, dx is going to be written as r dz dr d theta. So that is the first thing to take note. Don't forget this. Then the next thing is that s squared plus y squared in cylindrical coordinates is r squared. Then we can also see that this is for x. So we can see that -1 is less than or equal to x, less than or equal to 1. What this means is that when we come to the x-axis, x starts from the negative and moves on to +1. So the x-axis has both the positive and the negative. So it means that this side and this side, we are interested in both sides of the x-axis. And let's go to the y-axis. This is for y. So you could see that the y-axis too is from negative root of 1 minus s squared less than or equal to y, less than or equal to the root of 1 minus s squared. Therefore, the y-axis too, we are looking at both sides of the y-axis. So this is my y-axis. We are interested in both the positive y and the negative y. So we are also interested in both sides. So since we are interested in both sides of the x-axis and both sides of the y-axis, then it implies that we are looking at the entire circle from the positive x-axis. We are going round the entire circle from 0 going round up to 2 pi. So that is the condition. Therefore, we can see that our theta will start from 0 is less than or equal to theta less than or equal to 2 pi. So that is first. This is our cylindrical coordinate. Then remember, our radius starts from 0 0 to somewhere here. So we can look for the radius by first considering this part. By considering this part, we can see that y is equal to the root of 1 minus s squared. When we square both sides, we will get y squared is equal to 1 minus s squared. And by grouping like terms, s squared plus y squared is equal to 1. But we can see from here that s squared plus y squared is r squared. Should be equal to 1. Therefore, r should be equal to 1. But remember, r starts from 0 and ends at 1. Therefore, we are saying that the range of r is going to be 0 is less than or equal to r, less than or equal to 1. Then, lastly, because we are looking at a 3D plane, our z-axis is going to be this. This is our z-axis. So if I should extend it, then I'm going to get some kind of a cylinder. So this is my z-axis. And under cylindrical coordinates, z is always equal to z. It doesn't change. Z is always equal to z. But we can see from here that our z is for this range. So we can say that s squared plus y squared is less than or equal to z, less than or equal to 2 minus s squared minus y squared. We can see that s squared plus y squared is less than or equal to z, less than or equal to 2 minus, I'm factorizing negative out, I'll get s squared plus y squared. Then we know that s squared plus y squared is r squared. So here becomes r squared is less than or equal to z, less than or equal to 2 minus r squared. So that becomes the range of r, the range of z. Therefore, let me write it here. We can say that r squared is less than or equal to z, less than or equal to 2 minus r. So this is another cylindrical coordinate. So our cylindrical coordinates are this, and this. Alright. So now we can write them down. So now we can form our integral. So in forming our integral, I'm going to start from the first one. Remember, dz, dy, dx is equal to this. So I'm going to start from the theta first. Theta must come first. So I am integrating from 0 to 2 pi, then followed by r, and we know that r starts from 0 to 1, so you integrate from 0 to 1, then followed by z, and we know that z is from r squared to 2 minus r, 2 minus r. So that is it. Then the next one is the function itself. Now remember, the function is x squared plus y squared. But we know that x squared plus y squared is r squared. So write r squared. Then all exponent 3 over 2. So all exponent 3 over 2. Then there is also an r here. This r. So you write r multiplied by r. Then followed by r. So r dz, dr, d theta. Remember dz, dy, dx. This dz, dy, dx is giving us r dz, dr, d theta. So r dz, dr, d theta. So that is it. So this is our new integral. This is our new integral. We need to evaluate this one. So we need to integrate this one. So to integrate this one, we are going to integrate this first, then followed by this, then the last one is going to be this. So let us start. Our first integration is to integrate from r squared to 2 minus r of this expression. Now this expression, r squared exponent 3 over 2 will be r cubed. So we are going to get r cubed here, then times r will give me r exponent 4 dz. Now if I integrate this with respect to r, if I integrate with respect to z, r squared is a constant, so I'm going to get r exponent 4 z from r squared to 2 minus r. Then I can slot in the value, so I have 2 minus r I am integrating with respect to z, so these values are z values. So I'm going to get r exponent 4 multiplied by z, which is 2 minus r, then minus the same thing, r exponent 4 multiplied by r squared. So by expanding, r exponent 4 times 2 will give me 2r exponent 4 minus r exponent 5. If r exponent 4 times r will be r exponent 5. Then minus r exponent 4 times r squared will be r exponent 6. So that is the expression. So the next thing is to integrate from here to here. So I'm going to integrate with respect to r. So that is going to be the integral from 0 to 1 of this new expression, which is 2r exponent 4 minus r exponent 5, then minus r exponent 6 with respect to r. With respect to r. So it means that here is going to be 2r exponent 5 over 5, then minus r exponent 6 over 6, then minus r exponent 7 over 7. I am integrating this from 0 to 1. So by putting in the values, I'm putting in 1, so I'll get 2 over 5. I'll get minus 1 over 6, then minus 1 over 7. Then when I also slot in 0, I'll get 0. Everything will tend to be 0. So let us calculate. 2 on 3 minus 1 on 6 minus 1 on 7 will give me 5 on 14. 5 on 14 minus 0. So I still have 5 on 14. So the next thing we need to do is to integrate. Now we are going to integrate with respect to theta. So I am integrating from 0 to 2 pi of this expression, which is 5 on 14 with respect to theta, and that is going to give me 5 on 14 theta. I'm integrating from 0 to 2 pi, and that is giving me 5 on 14 2 pi minus 5 on 14 0. So the final result is going to be 2 will cancel 14, 7. So I'll have 5 pi on 7 minus 0, and the final result is 5 pi on 7. So that is the solution to this question.